Okay folks, here we go. We're ready for our third video in chapter 2. This is all about normal distributions. This one's a little bit longer than the last two, so hopefully you have a nice comfortable seat and you have your desk, your notes in front of you. And here we go. We're going to talk about normal distributions. One particularly important class of density curves are the normal curves. And the normal curves describe normal distributions. So a couple of characteristics. All normal curves are symmetric, single-peaked, and bell-shaped. A specific normal curve will be described by giving both the mean, mu, and the standard deviation. And you can see that normal curves can have different sizes. The one on the left is a short little fat one. The one on the right is a tall skinny one. But they are both normal curves because they both show the mean, mu, and the standard deviation. They're both symmetric, they're both single peaked, and they both have a bell shape. Alright, so normal distribution. We can estimate the proportion of people who lie between each standard deviation. Here's the standard normal curve. So you're going to get really good at drawing this curve. You're going to have to be able to draw it. The mean x-bar always goes at the center. Then you count over one standard deviation. So a rough approximation is that 34% of the population lies between the mean and plus one standard deviations. Now these things are symmetric, so that means on the left is also 34%. So altogether, 34 and 34 is 68% of the population lies within one standard deviation of the mean. The next section of the graph, that section there in green, is 13.5%. So approximately 13.5% of the population will lie between 1 and 2 standard deviations. And again, since it's symmetric, you know that the other section, on the other side, is also 13.5%. If we add all of those up, we get 95% of the population will lie within 2 standard deviations of the mean. So 95% of our data in a normal curve will be within 2 standard deviations of the mean. That leaves us then with the last little piece. So the last little piece out in the corners, in the tails, is about 2.5%. Now these numbers are approximations. You can get pretty close. They're not exactly right, but they allow you to get really good estimations. So about 2.5% lie in the two tails, and altogether that adds up to 100%. So there are many, many different normal curves, and we saw a couple of them earlier. One short and fat, and one tall and skinny, but they all have the same properties in common. So the first property they all share is something called the empirical rule. It's the 68, 95, 99.7 rule. And that says that in a normal distribution, 68% of the observations will fall within sigma, within 1 standard deviation of mu. 95% will fall within 2 sigmas, and 99.7 will fall within 3 sigmas. So you want to be able to draw this chart that you can see across the bottom. Alright, so you should practice drawing that. You should draw that out. It's written on your paper for you, but you need to know those numbers. You have to memorize them. Alright, so then how do we use this? The distribution of Iowa Test of Basic Skills vocabulary scores for 7th grade students in Gary, Indiana. The Iowa Test of Basic Skills is something that a lot of students take in middle school to basically figure out how they're doing. And so it's a normal distribution with a mean of 6.84 and a standard deviation of 1.55. So a couple of questions, typical questions that you would expect to see on a test or a quiz. First, sketch the normal density curve for this distribution. So that's what it would look like. You would put the mean, 6.84, right down the middle, and then you would add 1.55, which gets you to 8.39, and then you'd add another 1.55, which gets you to 9.94, and then you'd add another 1.55, which gets you to 11.49. In the other direction, you subtract 6.84 minus 1.55, and then minus another 1.55, and then minus another 1.55. All right, so that's your normal curve. The second question is, what percent of the vocabulary scores are less than 3.74? Well, if you have the normal curve, you can see by filling in the blanks using our numbers that 95% of the scores are within 2 standard deviations. So the red area represents 95%. The green area is 2.5%. And that was the question. What percent of the scores are less than 3.74? So we would say about 2.5%. The third question was, what percent are between 5.29 and 9.94. And again, on the curve, you can shade in the areas between 5.29 and 9.94. The two reds plus the green, if you add all of those together, you would get 34 plus 34, which is 68, plus another 13.5, you would get 81.5%, are between 5.29 and 9.94. Alright, so that's one of the ways you might use a normal distribution to help you calculate percentages and problems. Okay, another example where we use normal distributions. One student states that he got a 640 on both the verbal and the math sections of the SAT, and he stated, I don't understand what went wrong. I feel stronger in math, but I got the same score. And the question is, did he do better in one than the other? Well, notice that the mean for the math was 455, and the mean for the verbal was 500 with a different standard deviation. Remember from previously, from what we did in class, we talked about standardized scores. So on the math, if he got a 640 minus an average 455 divided by a standard deviation of 100, let's calculate his standardized score. So I'll get my calculator out. 640 minus 455 divided by 100, and I get a z-score of 1.85. So he's 1.85 standard deviations above average. Then let's calculate it for the verbal. 640 minus 500 over 85. So that's 140 divided by 85, 1.65. So he actually did do better in math. He was farther above average in the math than he was in the verbal. So that's an example of the way you will use z-scores to make comparisons. Alright, so all normal distributions are the same if we measure the units in size sigma from the mean as the center. So we get to a standard normal distribution if we use a mean of 0 and a standard deviation of 1. So when I say the standard normal curve, I'm talking about a mean of 0 and a standard deviation of 1. And standardizing allows us to change the units so that we can compare them. So here's the standard normal distribution. It's the normal distribution with a mean of 0 and a standard deviation of 1. We write it with the normal symbol. There's our formula for z-score that we learned in the previous video. And you have the standard normal distribution with n of 0, 1, which is called a z-score. So you want to definitely have that written down somewhere. The standard normal table. Now this is something that's in the back of your book. Because all normal distributions are the same, when we standardize, we can find areas under a normal curve from a single table. This is what they used to use back before the days of calculators. So before calculators became so prevalent, statisticians would have to use a standard normal table. The standard normal table, Table A in the back of your book. Some point tonight you want to take a minute to locate Table A in the back of your book. It's the table of areas under the standard normal curve. And the table entry for each value z, it's all based on z-scores, is to the left. So here's a small little piece of the standard normal curve, the standard normal table. If we want to find the proportion of observations from the standard normal distribution that are less than 0.81, we use Table A. So in other words, we want to find the probability that z is less than 0.81. So we would go down to 0.8, because that's what we're interested in, and then we would go over to 0.01, and we would see 0.791, and that would be the area that's less than 0.81. Alright, that's the way you use a normal curve. What about the proportion of observations from the standard normal distribution that are between negative 1.25 and 0.81? So area to the left of 0.81, we would use the standard normal curve, we just did it a minute ago, the table, to find that it was 0.791. Then we would use the table, we'd look up negative 1.25 in the back of the book, and that area corresponds to 0.1056. And then we want to find the area between them, so we would have to subtract. And we would get that the missing area is 0.6854. Right, so that's the way you would use the standard normal table to help you find the area under a curve. You can do this in many different ways. Right? You can use the same thing by doing it this way. You could find the area to the left of 1.056, calculate the area to the right of 0.81, and then you could simply do the math to figure out the missing part. You get the same answer. The top method is the method we generally use, but the bottom method also works well. Alright, how to solve problems involving normal distributions. So step 1, state. Express the problem in terms of the observed variable x. Then plan. Draw a picture of the distribution and shade the area. You always, whenever you're dealing with a normal distribution, you must draw the curve and shade the area. It is a requirement. Then perform the calculations, either using table A in the back of the book, or I'm going to show you in class tomorrow how to use your calculator. You have to standardize, so you want to get a z-score so that you can standardize it, and then you use table A to look it up. And then finally conclude, and remember in statistics the conclusion is the important part. You want to write your conclusion in the context of the problem. So state, plan, do, conclude. It's very, very important. Alright, so here's another example. When Tiger Woods hits his driver, the distance the ball travels can be described by a normal curve with a mean of 304 yards with a standard deviation of 8. The question is, what percent of Tiger's drives travel between 305 and 325 yards? So first, we want to draw a picture of what we're looking for. The mean is 304. I counted over by 8s, and we want to know between 305 and 325. Alright, so there's our picture, and there's the area we're interested in. Next, we're going to standardize, so we find the z-score for 305. So 305 minus 304 over 8, and we get a z-score of 0.13. Then we find the z-score for 325, and we get 2.63. Next up, use the table to figure out the area. So the z-score of 2.63 is the one on the left. We find that area. We subtract it from the area that corresponds to 0.13, and that would get the missing area that we're interested in. So using table A, we can calculate all these different things. And we figure out that about 44% of Tiger's drives will travel between 305 and 325 yards. For homework, I'd like for you to try those same steps on the next 5 problems about baby birth weight, and you're going to share them with your groups when you come into class tomorrow, and we will go over and talk about them. Good luck.
That's all, folks.
And I will see you tomorrow.